24-2. Okay, so in this example, it's saying that an AC generator with maximum voltage of 24.0 volt and frequency of 60.0 hertz is connected with a resistance of 265 ohms. So let's draw the picture here first. So we have a source, an AC source. So that's the AC source. Has the angular frequency omega. Has a resistor connected to it. Resistor R. Okay. So that's basically our simple circuit right here. The question is, with this given information, we have to find the RMS voltage. A. Find the RMS voltage. B. The RMS current in the circuit. RMS current flowing through the circuit. In addition, determine the average power. C. What's your average power would be? P average. And power, you know that it would be in terms of watts, right? D. The maximum power dissipated in the resistor right here. Okay. So it would be P max. What's gonna be the power over there? Okay. So remember from the previous example, we had the relationship. Let me write in blue for solution. The relationship between Vrms and Vmax. So Vrms is actually 1 over square root of 2 Vmax. Because we technically knowing that in the in an AC circuit, right? An AC circuit. So let me draw out the diagram right here. An AC circuit, we have Vmax here and negative Vmax, because AC means alternating current. Therefore, your source of voltage is going to be alternating up and down, like that, right? If we have to find the average values of the Vmax and V negative Vmax, then the average value is going to be 0. So that doesn't give us any information. Therefore, we use Vrms instead of V average, because V average doesn't give us anything. And Vrms has a relationship with Vmax, with this Vmax right here is equal to 1 over square root of 2 times Vmax. Okay. Alright. So part A, Vrms equal to 1 over square root of 2 multiplied by Vmax, and Vmax is 24.0 volt. So with that, we would get 17.0 volt for part A. Let's do yellow for part B. Easier to distinguish between parts. Okay. Once we know Vrms, can you find the current? The root mean square current. We got the root mean square voltage, right? We got the resistance that flowing through the circuit. Can we find the current? The answer is yes, using Ohm's law. So based on Ohm's law, we have I equal to V over R, right? So IRMS, or current, root mean square current, would equal to root mean square voltage divided by the resistance. And that would be 17.0 volt divided by 265 ohms. That should give you 0.0642 amperes. That's the answer for part B. Okay, do green for part C. Okay, so part C, what would be your average power? So the current, root mean square current, give us the information about the mean of the current in this alternating circuit, in this AC circuit right here. So to find the average power, we use this formula, right? Because IRMS give us the mean of the current that flowing through the AC circuit. And we know power is I squared times resistance. Root mean square current, we just found in part B, 0.0624642 amps square multiplied by your resistors values, 265 ohms. 265 ohms. Now your average power should be 1.09 watts. Alright, part D. Okay, so we got the average power that the circuits consume. That the average power that the circuit consume, right? Now we have to find the maximum power at which the resistor, at which is dissipating in the resistor. Because we have the resistor right here. How much power is dissipated through this resistor right here? So to do that, we use this formula. Pmax would be Vmax, because it's the maximum value, square divided by R, to find the maximum power. And that would give us our Vmax is what? 24.0 square, 265 ohms. That should give you 18 or 17 watts. Okay. So from this relationship, we can see that maximum power is dissipated through the resistor is more than twice the average power